So in this class, we are going to consider as a continuation working with the trigonometric graphs as part of the trigonometry. You need also the basics as you are to consider the trig graphs. So in our case, we are going to focus with the sine graph. The sine graph. The basics of the graph of a sine under the trigonometry, which is an important aspect for us to consider. In our case, we are going to actually sketch the graphs that are important and the effects, which are the transformations that can actually occur on that graph. So if we are given the sine graph, this is not the first time having this, remember, from our grade 10 mathematics, we had such, all right, when you're given the graph of a sine, and it was just the basics that we had there. So our case, we are going to consider the graph being taken as y is equal to a, the sine of bx. Then we can also have an effect of p, which can be plus or minus, all right? We can also have the effect of what? Of q, which can be also a plus or a minus. So in order for us to understand this graph, after these effects, the A, the B, the P, and the Q, we must understand a simple graph of a sine when y is taken as the sine of x or the sine of theta. Then these effects or transformations, we can apply them on that graph. We are going to consider another class where we are going to use a calculator in order for us to simply sketch the given graph, right? But for the case of understanding, for those who want to understand where exactly it was taken from, this is your class. It is very, very important for you to understand, these basics. Before you move on, you must understand all the given information that is on the graph of a sine. So like I said, we are going to start with the graph of a sine as a basic graph to say y is equal to the sine of x. For you to have this graph, you will be given an interval for which values of x are you going to take from as your input to give us the corresponding y values. It must be from a certain interval, which is the input. So taking our graph, all right, let's say our graph, we're going to take it for the x values. Let us take from 0 to 360 for our x values, taken from what? 0 degrees up to 360 degrees. We can have our graph. So the graph of a sine and the graph of a cos, I need us to understand those two. If we are to if we are to sketch this graph, it has a spacing of 90 degrees. The basic graph of a sine of x without effects. There is no effect when you just sine of x, like there's no effect. We haven't added or subtracted anything, or there's no effect there. The spacing is 90 degrees, meaning to say we separate our angles. If we are to say this is 0 degrees, 90 degrees, and so on, we are going to space them 90, 90, and so on. So in my case, I'm just going to take these two boxes for the sake of the space that I'm having. So this will be 90. We add 90, that is going to be 180, 270, 360 degrees. So it's going to be, and so on and so on. But for the given interval that we are working with, from 0 to 360, with a spacing of 90 degrees, then the output, now we can have this 1, 2, 3, and so on. Where there is an effect, we are going to see that effect. All right. Where there is an effect, we consider those. But in our case, we do not have. So we're just going to. So we take it for the graph of what? The sine of x. So there is no need for us to have these 2, 3, and so on. But just for the sake of understanding, this is what we are going to have. All right. So with the x values and the spacing of 90 degrees, I can use a table in this case where I have x as the input, y as the output, the table of what? Of values. So we can have x and y, all right? So like we have our spacing from 0 degrees, we've got 90, 180, 270 up to 360 degrees. For these x values, we are going to have the corresponding y values. Substituting into x, into our sign there, we substitute the value of x. So in our case, guys, let us just quickly have this. The sign of what? We're going to start with the 0 there, sign of 0. That is what? A 0. We move on 90 degrees. We put 90 here. That is going to give us a 1. 180 degrees, 180, that's a 0 there. Then we have got 270, all right, 270, which is -1, 360, all right. Let us just quickly have these ones. 360, that's what? At 0. So this is what you're going to have. So yeah, I just want you guys to see how it was going to be like. But in case of revision, there's no actual need for you to have this. If you had your grade 10 mathematics, remember, those were the values. But okay, let's have it on our graph. It's x as the angle, the y value corresponding to the value that we substituted there. So when x is 0, we're going to substitute that point of what? Of 0 versus a 0. That is on the what? On the origin. We move on. The next point, 90 versus 1. So that's 90 on x and 1 on y. So that is like this. These two are going to meet at that point. That is 90 versus 1. The next point is 180 versus what? 180 versus 0. So that's 180 degrees, and that's 0 in the what? In the x-axis. 270 versus -1. This is 270. And -1, that is in the negative. This was going to meet at this point. And the last one is 360 versus what? 360 versus 0, which is on the x-axis. So with these points, if we were to join, we're going to have the graph of what? Of a sine, like this, by joining these points. Joining the points. This is it. We have the graph of what? Of a sine. Y is equal to the sine of x. So before we look into these effects, it is important for you to understand as a basic graph as it is like the sine of x limited from where the minimum value being -1, maximum value being what? +1. We cannot exceed that. when it is y is equal to what? Sine of x, unless there is a certain effect. But on the original graph as it is like this, it will be limited from -1 up to 1. This is what we have as our range. So you can actually say our range in that case, the y values from -1 up to 1. So y will be taken from -1 up to 1. This is what you're going to have. The domain being the x values. So the domain is going to depend with the given interval. So as of the domain there, x will be the part of what? The given interval. What is it that you are given on your interval here? According to our question is from what? 0 to 360. So in our case, our domain was going to be simply this. The given interval is your domain. As we can see our graph, it has turning points also. A maximum turning point at what? 90 degrees versus what? Where we have a maximum turning point. At this point, 90 degrees versus what? Versus what? X is 90 degrees, Y is what? A minimum turning point at 270 degrees versus what? -1. That's a minimum turning point. So also, as this graph, there is what we refer to as the period of the graph. So the period of the graph is where we consider the full cycle of the graph. This is the graph of a sine of x. When it is a complete cycle, it is supposed to be this half combined to the other half. All right. So that is, let's say, our half somewhere here. We are saying this half added to this half, it's a complete cycle. So we have got half and a half. So in our case, if we are to look at this one properly, we can see that from 0 to what? To 180 degrees. It's a half cycle, that one. It's half of what we see on the other side here. From 180 to what? To 360. That's another half. Only that it's below the x-axis. This one is above the x-axis. So we say this half, it took how many degrees for us to have it? 180. What about this half? From 180 to 360 is what? 180. So at the end, if we take this 180 and this 180, it is going to give us what? 360 degrees. So the period of a graph of a sine is what? 360 degrees, where we have a complete cycle, 360 degrees. The first half occurs in 180 degrees. The second half occurs in what? 180 degrees. So the combination of these two, they give us a complete cycle. That's our period. So this is what you need to actually understand. The period of the graph, the amplitude of the graph. So the amplitude of the graph, when it is the graph of a sine of x, you can just take it from this. Y is equal to the sine of x. So it is the number that is affecting that. So it is 1. It means our amplitude is 1. So it's like y is equal to a sine of x. A is what? The amplitude. A represents the amplitude when it is y is equal to a sine x. There is no effect in that case. So in our case, our amplitude will be 1. Will be equal to 1. But if there is any effect, guys, if there is any effect that is you do not understand, calculate the amplitude. calculate it. From which formula? The amplitude is simply taken, remember, from your grade 10 mathematics, we said this is supposed to be maximum value minus the minimum value over what? Over 2. So if you take, for an example of what we have, the maximum value, we talk about the y values. The function is of y. Remember, the graph is for y. So the y value is what? Is 1, the maximum value. So it was going to be 1 minus the minimum value. The y value is what? Negative 1. Everything over 2. So that's a plus 1 plus 1, which is 2 over 2. And that was going to give us a 1. You won't go wrong by using this formula in case that you do not understand this part of what? Of the amplitude. Maximum minus minimum over what? Over 2. It is going to give you the amplitude of the given graph. So this is the basic. This is the basic of the sine of x. So when we have this now as y is equal to a sine bx, there are effects to the graph. The a is its own effect. So the question is, what is that effect of a? What is the effect? So a in our case is going to affect the maximum and minimum values. Let's say y is equal to a sine of x. Without any other effect, the a that we see is going to be exactly here, a, and this one is going to be minus a, maximum and minimum values. But guys, this is not the same when we have got a graph like maybe y is equal to 2 sine of x. Then there is a minus there, maybe minus 3. It is been affected. It was supposed to have maximum value at 2 when it was like this. When it was like this, it was supposed to be the maximum value at 2 at what? At minus 2. But because of this minus 3, guys, it means that the graph is going down. So the 2 that we see is going down. So its maximum value 2 minus 3 will end up at minus 1. Where we see that maximum value, this maximum value like this, guys, it will be at minus 1. At minus 1. So meaning to say the graph will be starting maybe something like this. It will be at minus 1. Then this one that we see at minus 2, it will be minus 2, minus 3. At minus 5, we're going to see it at minus 5. So it won't be to say that A there represents the maximum value. No. It will be an effect now. When combined like this, there are so many effects to be referred to. But when it is just A sine x, guys, please do not get confused there. When it is just A sine x, it is the only effect that is on the graph of sine. The A will be for the maximum and minimum. It represents the amplitude. It will be your amplitude, which is the maximum minus the minimum value, then you divide by 2. That case, you won't go wrong. So we are not going to take to say A is going to be for the maximum value. When we say the maximum value of the graph, it is like here, the maximum where it is having the turning point, the maximum turning point, minimum turning point. There's a difference. So like what we had, we'll be having something like minus 1 and we'll be having something here like what? Minus 5. The A being the amplitude can be determined. So here we are going to have the amplitude. So that is what we are going to have as a part of our calculation to say A is what? Is the amplitude, which can be determined. But we saw the effects, how it's going to be like when it is like this, the understanding of that A, that you just say, okay, the number that I'm having here as it is, this is the, when it is 2, this is 2, this is minus 2. But when there's another effect now, it won't be like that. But if you calculate your amplitude, the way that you calculate your amplitude, you will still get the same answer. Maximum minus the minimum value divided by 2, maximum minus the minimum value divided by 2, will get the same answer of what? Of the amplitude, which is the value of the A. So that number, don't look into the maximum as we saw from the previous. What I'm trying to say here is that most of you guys, you tend to confuse it because you have got the graph of a sine like this one. So you just say, okay, because it is at what? At 1. So that's why our amplitude here is what? Is 1. But we saw it maximum minus minimum over 2. But because of this graph that we have of a sine of x, we can just look into it to say, okay, there's a 1 here. That is our amplitude. All right, there's a 2, that is our amplitude. All right, there's a 3, that is our amplitude. But when there is a shift in the graph, or on the graph that you're given, whenever there's a shift like this, you cannot just look into that point, then you say, all right, at minus 1, so I'm going to use minus 1 as the amplitude. No, you must calculate it properly. But for these ones, guys, where you see minus 2 and a positive 2, just take that 2, it's your amplitude, as a positive. Okay, so I hope that we're not going to have a confusion. If you have a confusion, guys, please go back to the formula. Use the formula. Always use what? The formula for you to determine what? The amplitude. Always use the formula. You won't go wrong. Always use the formula. Always. So that is, maybe we can cut that story to say we have got what? A as our amplitude. Maximum. All right. Maximum minus the minimum value over what? Over 2. B is going to be another effect. Y is equal to sine 2x. Y is equal to sine 3x. This part here, it represents the number of cycles per specified time interval. Meaning to say, when you're given 2x, it means 2 cycles that we are going to complete. Remember the graph of sine x. In 360 degrees, it has got 1 cycle. This is 1, a complete cycle. But when it is now sine 2x, it means in those 360 degrees, it is going to be 2 cycles. We are going to have 2 graphs completed there. All right, we are going to see those effects. But for now, that is what I can just say for us to write something. It is number of complete cycles. Number of what? Complete cycles per specified interval. Okay? Per specified interval. Number of complete cycles. So the effect of B, I'm going to refer it later on, the effect of B. And also, so let us just leave a space for that one because we're going to talk about that effect. Then P can be added to whatever that you're given. Is it sine x plus 30 degrees? Is it sine x minus 30 degrees? Direct on what? On X. Direct on X. Added or subtracted direct on X. It is a horizontal shift, which is called a phase shift. So that's a horizontal shift. Remember, guys, I talked about transformation. Make sure that you watch the video on transformations. All right, horizontal shift. Okay, we're gonna also look into that one later on. Now let's just write then Q to be for a vertical. It can be plus, it can be minus that one. So that's a vertical shift. So guys, I talked about these on the transformations. All right, so make sure that you watch the video, understand all the basics. That is very, very important. So let's start with A, the effect of A. The effect of A will be on the amplitude. So when it is from this graph of A, this one that you're given of sine X, without any other effect, it will be just changing the maximum and minimum value. In that case, guys, it will be just a direct one, all right? So let's just, the effect of what? The effect of what? The effect of A. That A is just going to affect, like, for an example, we are to draw the graph of Y is equal to 3 sine X. 3 sine X. There is no other effect that we have there. There is no other effect. It's just the 3 that you are given there. It simply means when we add these angles, guys, when you're multiplying 3 sine, whatever, that's substituting your values from 0 to 180. This one will be multiplied by 3. So this will be 3. This will be minus 3. That's the only thing that is going to happen. Our maximum value where it was at 1, we are going to see it now, it will be at 3. So you're going to have 90 degrees versus 3. The same on the minimum value at minus 1, we are going to have it at what? At minus 3. 270 degrees versus minus 3. All these points, the x values will remain where they are. When multiplied by 3, there is no effect. They will remain where they are. So meaning to say our graph in this case, if we are going to draw this graph from the origin to the point 3, 90 degrees versus 3. This is where we are going to have it. Then it goes back to the 180 versus 0 there on the origin to this one. All right, then it goes back to 360. So this is how our graph now is going to be like 3 sine of what? 3 sine of x. But remember, it is just a direct, we just applied a direct effect of A on the sine of x. So if we take it that way, we might not have the proper understanding, all right? So it will be best when you're dealing with question papers where we can properly see this effect, all right? But when it is just a single graph like sine of x, then you have that effect of 3 is just going to affect your maximum to the minimum. We do not have a vertical shift so far because this vertical shift, guys, it is affecting our graph at the end. So when there's a vertical shift, we are not going to have this graph at 3 or minus 3. Because maybe it is shifted minus 2. It means the 3 will go down 2 units. This one that we have at the minimum value is also going to go down 2 units. But as of the effect of A direct on its own without any other effect, that is how the graph is going to look like. Remember, the graph is not affected by one transformation or by one effect. It can be affected by all of these effects that are listed here. So that is how you simply attempt that one. All right. With the A that you're given. So let's move on to another effect. All right. We can talk about the shift, the vertical shift. I think that can be easier for us to understand the effect of what? Of Q as the vertical shift. All right. So this one, let me just remove the graph that we just had now. All right. We want to have that one. Everything, I'm going to refer it back to the graph of a sine, this one, because these are effects from the graph of a sine. So that is why we do not have to redraw even the table there. All right. We can have the effect of what? Of Q, which is the vertical shift. The effect of what? Q. How is Q going to affect our graph? It is a vertical shift, meaning to say our graph can be taken up or it can be taken down. As we are to consider our function, the graph of a sine, we can have it going up or going down. Positive Q, that is going up, and negative Q when it is going down. So meaning to say, on the graph that you are given, if you are given a graph of the sine of x, then there is the effect of Q. We can have this maybe sine of x, then we're going to subtract 3. We can have maybe the sine of x, then we're going to add a 2. We can have anything. Minus sine of x, minus 2. But now the minus there, it is what? It is also an effect from the A that we had. If we multiply these numbers by negative, it means the points will actually will change. It can be minus, it can be positive. So you must have a graph that you consider from, to say, from the graph of minus sine x, then I'm going to have minus sine x minus 2. From the graph of sine x, therefore I'm going to have sine x plus 2. So positive Q, you shift going up. Remember, guys, we talked about these transformations before when we dealt with the algebraic graphs, those parabolas and so on. Positive Q, you're going up. Vertical shift. Negative, you're going down. So meaning to say, on the original graph of the sine of x, it is simply shifting this graph up or down. Maybe 1 unit. So you're going to go 1 unit as it is, 1 unit. So it will end up like this. We have shifted this graph 1 unit up. It is 2 units that we have. It means this graph was going to move up. This is 2 units. So end up our graph like this. Now it's at 90 versus 3 when it was given as y is equal to sine of x plus what? Plus 2. We shift this graph 2 units up. So the 0 there had to move 1, 2. The one that was here to move 1, 2 according to our values that we have on our Cartesian plane. The minus 1, which was here to move 1, 2 up to here. The 360 degrees at 0 to move 1, 2 going up. That is the effect of what? The vertical shift. All right. Or let me do this way. Let me try to see if I can just have 1 or 2. Let's see. Drag to copy. There's no paste. Copy. All right. But now how do I paste it? All right, let's see. Okay, this is it. All right, this is it. This is it. So this was our original graph. I want us to see the way that it was. It was like this. This was our original graph. This one. Y is equal to what? Sine of x. So when we now have sine of x plus 2, the original graph from where it was here. Then we have to move it 2 units up from 0 to 1. Then we move up again to 2. So from 0 now, this one is at 2. So the graph is now this. Y is equal to the sine of x plus what? Plus 2. If we had a negative, y is equal to the sine of x minus 1. It means this graph is supposed to be going down. The graph of what? Sine. Original graph. Going down. 1 unit. Just like that. So are we seeing, guys, that with this information, you can answer any question? With this understanding, it will be like this at negative 1. All right. I want us to bring this to where it was. Like this. 1 unit down. So it means the 0 is now at what? Is now at minus 1. The 1 which was 90 degrees, it moved 1 unit down. It's now at 0. We had 180 versus it's now at what? At negative 1. The 27, which was at minus 1, 1 unit going down. It's now at what? Minus 2. The 360 versus 0, 1 unit going down. It's now at what? 360 versus minus 1. It's a shift. So you must be able to tell, guys, it is still the same shape. Only that the graph is now taken up or it is taken down. So you must be able to tell, all right, this graph is just moved. How many units going up? Compare even 1 point to say this at the origin at 0, because you know the 1 of sine x. So you compare with it was, okay, 0 is here. But on the other graph now, I'm having what? 2. Here, I'm having a 2. So how many units? 1, 2 going up. The same thing, 1, 2 going up. So I know that from this graph of a sine, they simply added a 2. That's my effect. What happened? The same shape, but the graph is now down. 1 unit going down. Each and every point is 1 unit going down. So I simply subtract a 1. That's the effect of what? Of the vertical shift Q. The graph can be taken up or it can be taken down, which is actually a different thing when we have the effect of P when it is a horizontal shift. When it is a horizontal shift. All right. Let's just consider that one. Then we look into the last one, which is the effect of the number of cycles. All right. So this one, let's just pause. I just want us to work with that original graph, this one. So that's why I do not want us to remove this information. I want us to go back to the same graph, use it to answer any other effect that we can have. All right. So this here, that was it for the graph of what? Sine of x being transformed vertically up or vertically down, the effect of what? Of Q. We can have such. The horizontal shift is on its own, which is the effect of what? Of P. It's on its own. Remember when we dealt with a horizontal shift from the functions and graphs where we're given f of x plus a, f of x minus a. I say that for f of x plus a, it means we are going to the left. A units to the left. A minus opposes the way that you take it to the right. A units to the right. Or simply solve to say, all right, x minus a is equal to 0. So x is equal to what? A positive. I'm going to the right. X is equal to negative. I'm going to the left. This is the concept. So it is the same thing on our graph. You'll be given the sine of x. Here we're just working with the sine of x. Plus or minus p. For an example, x, y is equal to the sine of x. All right, let us just have something like the sine of x plus 60. The sine of x minus 30 degrees. It was sine x before. Now it's x plus 30. What happened? In place of the x, we substituted f of. It was f of x given. Now it is in place of x, we substituted f of x plus 60 degrees. In place of x. In place of x from the graph of what? Y is equal to sine of x. In place of that x, we substituted x plus what? X plus 60. It's f of. F of x plus a means what? We are going to the left. Plus. So it is the same thing. This is the effect. When it is like this, it means 60 degrees to the left. That's our effect. Horizontally. 60 degrees to the left. So the same thing given the sine of x, taken from where? If it is taken from the sine of x, it means for us to have x minus 30, we simply substituted that in place of x. So it was f of what? X minus 30. F of x minus a. A units to the right. So how many units? 30 degrees to the right. So it simply means 30 degrees to the right. Just like before. 30 units to the right. So this is an effect, guys, which actually affects our graph to say the graph is moving. We are to shift it. We are to shift our graph to say these, okay, let's just work with the critical values because in our case, it's just a shift going to the left or to the right. The maximum, minimum values, like to say it was at 1, is going to be remaining at 1, only that it is going to be shifted in terms of the x values. The y values are not affected. Sorry for that. The y values are not affected. So I'm going to give us, and I'm going to work with this example here. F of what? X plus 60 degrees. Y is equal to sine x plus 60 degrees. So if we are to have the graph of y is equal to the sine of x plus 60 degrees, from 0 to 360 as we are given as our interval. But remember, we say this is a shift, a horizontal shift. The graph is shifted, going to the left, 60 degrees to the what? To the left. So what does it mean? I'm going to work with the critical values. The critical values, I'm talking about the points that we have there. It means the 0 degrees will be taken, shifted to the left, 60 degrees, all right? Remember this, going to the negative, it was going to be negative 90. We are not going to consider the negative because of what the interval from 0 to 360, but I just want you to see how it was going to look like. So the 0 degrees here will be at negative 60. We are going to the left, so it's 0 minus 60. All right, according to this, it can be 45 here. So minus 60, let us just say somewhere there. Minus what? 60 degrees. All right. The 90 degrees will be taken again 60 degrees to the what? To the left. So if this is 45, if we take 60 degrees to the left, 90 minus 60 is what? We are saying 90 minus 60 to the left. We are subtracting that. So it's going to be at what? 30 degrees. Where 90 degrees was on the original graph, now it's at 30. It has been shifted to 30 degrees. We now look into the 90 degrees as 30 degrees, meaning to say its properties will be the same. The properties of what? Of 90 degrees, to say it's 90 degrees versus 1, is going to be 30 degrees versus 1. Here, this will be your maximum turning point. 30 degrees versus what? 30, versus 1. This is the shift that we're talking about. What was happening at 90 is now happening at 60. It has gone to the left. What was happening at 180 versus 0, it is now occurring where we subtract 180 minus 60. We are going to the left at 120. So this is now happening at 120. This is the idea, all right? Maybe somewhere there, this is where we've got what? Our 120 degrees. So it's 120 versus 0 because it was 180 versus 0. So also 180 versus 0 is not going to change. What was happening at 270 versus minus 1 is going to happen 60 degrees back to the left. So 270 minus what? 60 degrees, which is going to be 210. So this is happening at what? 210. So it was at 210 degrees versus what? Minus 1. Remember, it's 270 versus minus 1. So it will be 210 versus what? Versus minus 1. What was happening at 360 degrees? We have taken it to the left, 60 degrees. So 360 minus 60. It is now happening at 300 degrees. So if it was 360 versus 0, it is now 300 degrees versus what? 300 degrees versus 0. So our graph now is going to be like this. From minus 60, all right, so this one I'm just going to use dotted lines because it's out of what? The interval from 0 to 360. From 0 to 360. So I'm just going to use a broken line up to where we get to the what? To the y-axis. Remember, we need 30 versus 1. So like this. All right, I can now start using continuous line, 30 versus 1. So our graph was going to be like this, to what? 120 versus 0, to 210 versus minus 1, to what? 300 degrees versus 0. So it has shifted 60 degrees to the left. 360 is now at 300. 270 versus 1 is now at what? 210 versus minus. It's now this one. 210 versus minus 1. What was happening at 90 degrees? 90 degrees versus 1. It is now happening at what? 30 degrees. 90 minus 60. It is now happening at 30 degrees. So this will be 30 degrees versus 1. There's a shift of 60 degrees to the left. This is it. So we are going to look into questions later on where they actually have to draw these graphs for you and you have to tell, all right, this is happening. So at least if you can tell this, you are the one who is to draw the graph, you can see, all right, this is what is happening. It will be easier for you to tell now when it is drawn for you. You can actually tell, all right, the graph here just was taken to the what? Was taken to the left. So when it is taken to the left 60 degrees, it means f of x plus 60 degrees. So meaning to say, in place of x, I'm going to substitute this. So the graph will be y is equal to sine x plus what? 60 degrees. Remember, in place of x, we substitute x plus 60. In that case, guys, you can draw, you can answer any question. Any question. This is the case. From the original graph, from what you're given. So if it was going to the right, when you substitute, it will be f of x minus, let's say it is 45 degrees to the right. You substitute it as minus. So meaning to say, from the graph of y is equal to sine of x, it will be transformed and the graph will be now y is equal to, in place of x, it will be sine of what? In place of x, it will be x minus 45 degrees. It means you are going to the right. Do not mistaken on that part. A positive, we are going to the left. So the graph has been shifted from where it was, going back like this, going like 360, it was going minus 10, minus 20, minus 30, minus 40, minus 50, minus 60. It maintains the same shape as it was, but only that is now taken down, taken some degrees to the what? To the left. The same when it is going to the right, we're going to have the same shape. The same shape. Maybe it is 30 degrees to the right. So it was going to be 0, 10, 20, 30. It will be like this. 30 degrees to the right. It will be something like this. It has shifted from 0 to 30. So meaning to say 90 degrees versus 1 will be shifted to another point. It will be 90, it will be now 120 versus 1. 180 to be now 210 versus what? Versus 0. What was happening at 270 is now happening at what? At 300. 300 degrees versus minus 1. We have shifted our graph 30 degrees to the what? To the right. So it have to move 30 degrees. If it is 90 degrees, it has to move up to here like this. If it is 1, you just have to consider what you're given. That is the shift. It will be just going like that from where it is horizontally. So the maximum values where it was having its maximum value before originally, to say the values of y, as you can see, it is still at 1, only that the x value has changed. It's now 30 versus 1. So it does not affect the range. It can affect our domain at the end. To say our graph, it will be taken from 0 to 300 if we are talking about that interval from 0 to 360. This is the effect. The effect of P. The horizontal shift. Then we also have B as the number of completed cycle. This B is going to affect a lot of things because as it is considering the completed cycles, remember the graph of a sine as it is. The graph of a sine, this one. A sine of x. We said it is affected from 0 to 360 degrees. Its complete cycle from 0 to 360 degrees. Which is okay. So meaning to say when we have now an effect like this condition of B where we are saying the number of cycles, what is going to be affected? It is going to affect the period, because sine of x, it completed its complete cycle in within what? 360 degrees. If we still remember properly. It was completed, the whole cycle, this one, was completed in what? 360 degrees. So when we now have an effect which affects the sine of x direct, as what we have there to say, okay, let me put it this way. Okay, let me just write it here. Let me just write it here. The effect of what? Of b. So when we have this b, it is going to affect the period and also the spacing, as b is about the number of complete cycles. So remember, a complete cycle, we talk about a period. So meaning to say, we are going to have a new period from there. We are going to have a new period. So the new period from the old one, the old is the one that we have on the graph of a sine. Its period is what? 360 degrees. So we are going to use the old period divided by b. For an example, in our case, for the graph of a sine, its period is 360. So therefore, it will be 360 degrees over what? Over b, the new period. It also affects the spacing. So it means our new spacing of the graph, how we are going to space our graph in terms of the angles. The graph of a sine, the angles were spaced 90, 90, 90, 90, 90, 90 degrees from each. So the new spacing from the 90 degrees of the graph of a sine, it will be 90 degrees over b. Old spacing over p. That is the effect of our b. So meaning to say, in our case, if we were to have this effect, let's say we are to draw the graph of y is equal to the sine of 2x sine bx from the graph of y is equal to the sine of x, which had a period of 360 degrees, and we know its spacing is what? 90 degrees. It means for the graph of y is equal to sine 2x, its period is going to be affected. We are going to have the new period, which is what? The old period from the graph of a sine of x. Its old period is what? 360. So that's 360 degrees over b. What is our b here? It's 2. So it is going to be having a period of 180 degrees, meaning to say it completes its cycle. A complete cycle is completed in 180 degrees. It will be having a complete cycle. So in 360 degrees, it has got how many cycles? 2 cycles. Guys, this does not only end there. The spacing as well is affected. So the new spacing of our graph will be what? Original spacing, which is 90 degrees for the graph of a sine, and the graph of a cos. They have got the same thing. So we divide by 2. That is going to be 45 degrees. So what I'm trying to say is that our new graph, which is the graph of y is equal to sine 2x, we are going to space it 45 degrees from each point for the x values. All right, let us just have our sketch from this one that we have. Remember, the graph of sine is our original graph. So using a spacing of 45 degrees as we have now, it means, all right, 90 degrees, and this will be half here. So this is 45 degrees, 90 degrees. We add the 45, that will be 135. 180 plus 45, that is going to be 225. 270 plus 45, that is going to be 315. We add 45, we get 360. So what is happening, guys, is that our graph has changed, remember. The spacing as we had before, to say 90 degrees was giving us a 1. This is now happening at 45 degrees according to the new spacing. 45 degrees is the one that is giving us a 1. So we have got 0, 45 versus what? Versus 1. What about 90 degrees? The 90 degrees, because we're taking from the original graph, guys, from 1, it was going to 0. So what was happening at 1880 there is now happening at what? At 90 degrees, it will be 0. 270 versus minus 1 is the one according to our spacing. 135 is the one that will be versus minus 1. What was happening at 360 is now happening at what? At 180 degrees. So if we are to check from 0 like this to 1 to this point to this point to 180, it is the graph of a sine, this one. It's a complete cycle, this one. So we have got one cycle there. But it has to continue, guys. From 225, according to that spacing, is going up to 1. 270, it goes down to 0. 315 to minus 1. 360 back at 0. So it was going to continue with that same pattern as the spacing of the previous graph, but only that it is now spaced 45 degrees from each. 45 degrees from each. So if we check properly, our graph has completed 2 cycles. The first cycle, a complete cycle at 180. The second cycle, this one is a graph of a sine which is complete. This one, as you can see, a complete graph. So there are 2 of them in 360 degrees. We have 2 these types of graph of a sine. There are 2 of them. So that is the meaning of that 2 that we see. This is the meaning. So if it was a half there to say this is a half of x, we do the same 360 divided by half. 90 divided by half. So it means in 360 degrees, it's going to take a half cycle. 360 degrees, it's actually a half cycle. So it will be from 0 to 360. It will be a half cycle like that. This is the case. Its complete cycle will be completed. Its new period, 360 divided by what? 360 divided by half, which will be happening at 720 degrees. It will complete its cycle at what? 720 degrees. That's where you're going to have a complete cycle from 0 to 720 degrees. Do revise as many questions as you can. The spacing is affected. The period is affected because of that effect of what? Of B. So this is how our graph was going to look like. So this is the graph of what? Y is equal to sine of what? Of 2x. 2 cycles in what? 360 degrees. So we are going to look into exam questions where these effects are to be actually maybe determined, where you have to determine the value of A, the value of B, the value of P, the value of Q. where they have drawn these two graphs for you, this and that. So, but as long you've got these basics, I think you can figure out from those graphs, all right, this graph has just been taken up, it has been taken to the left, it has been stretched. Like you see, the 2x is like a stretch. We are stretching our graph in or out. Is it affecting the maximum value to say our graph is the same, but it is now taken to a maximum? No, each and every effect. And when these effects are combined, they can take two effects, combine them together, whether it is going up and where the period is also affected. Just like what we used on those functions. There can be two transformations explained or discussed. You must be able to figure out those effects, those transformations. So please, guys, let us do revise as many questions. We shall meet again in the next class.